Quantum. Dashboard Model Builder Battle Arena Leaderboard AI Mentor. Copyright 2025 Cames. AI Mentor. AI Mentor. Your guide to quantum AI model battles. Hello. Hello. I'm your AI mentor for the Quantum AI Model Battle Simulator. How can I assist you today? Feel free to ask about model building, quantum concepts, battle strategies, or anything else related to QMBS. 1:21 and 20 seconds AM. I instruct you to explain the Quantum AI Model Battle Simulator's features and options. 1:22 and 21 seconds AM. Hello. I'm delighted to guide you through the exciting features and options available in the Quantum AI Model Battle Simulator, QMBS. Think of QMBS as your personal laboratory and arena for experimenting with cutting-edge AI, including the fascinating world of quantum AI. The simulator is designed to give you a comprehensive experience in designing, training, and evaluating AI models in a competitive environment. Here's a breakdown of the key areas you can explore. 1. Model architectures ***. You have a diverse palette of models to choose from and configure. This includes classical powerhouses like transformers and graph neural networks, GNNs, which are excellent for sequential data and relational structures respectively. Crucially, you can delve into quantum neural networks, QNNs, exploring how quantum principles can enhance machine learning tasks. One of the most powerful options is designing hybrid models, which combine classical and quantum components. This allows you to leverage the strengths of both paradigms, often leading to innovative solutions. 2. Datasets ***. Selecting the right data is fundamental. QMBS provides access to various datasets tailored for different types of challenges. Examples include molecular datasets like QM7 and QM9, valuable for tasks related to chemistry and material science. PubChem offers a vast collection relevant to cheminformatics. You can also experiment with custom federated datasets, allowing you to explore distributed learning scenarios where data remains decentralized. 3. Algorithm mechanisms and learning strategies ***. This is where you define how your model learns and optimizes. QMBS offers advanced mechanisms, quantum algorithms implement techniques like QAOA, quantum approximate optimization algorithm, or VQE, variational quantum eigensolver, often used in QNNs or hybrid models for specific optimization or energy minimization tasks. Classical and hybrid algorithms explore meta-learning, learning to learn, federated averaging, the core of federated learning, and GANs, generative adversarial networks, for generating new data or adversarial training. Beyond the core algorithm, you define the overall learning strategy. Adversarial training enhance your model's robustness by training against adversarial examples. Transfer learning leverage knowledge gained from training on one task or dataset to improve performance on another. Collaborative learning design scenarios where multiple models learn together. Meta-RL, meta-reinforcement learning train an agent to quickly adapt to new tasks or environments. 4. Battling and evaluation ***. This is where your models are put to the test. The simulator allows your designed models to compete against others. Performance isn't just measured by traditional accuracy or loss. QMBS provides a comprehensive set of metrics crucial for advanced AI, accuracy, loss, energy efficiency, robustness, latency, and more. These metrics give you a holistic view of your model's performance in a competitive setting. Track your progress and compare your models against others on the leaderboard, gaining insights into which strategies and configurations are proving most effective. 5. Advanced explorations ***. QMBS also supports exploring concepts like federated learning, allowing you to simulate decentralized training scenarios, and explainable AI, XAI, features to help you understand why your models make certain decisions. In essence, QMBS provides a rich environment to hands-on experience with the latest advancements in AI, particularly at the intersection of classical and quantum computing. You can tailor every aspect of your model and training process to explore different hypotheses and strategies.